The query planner never reads your data to pick a plan. It reads statistics. When those statistics are wrong or missing, the planner makes bad guesses, and you pay for it at runtime. Analyze samples up to the default statistics target of rows per page and builds two key structures, a most common values list with exact frequencies and an equal depth histogram for the rest. The planner multiplies selectivities across predicates to estimate output rows. When you run analyze, Postgres samples heap pages, computes statistics, and writes rows into PG_statistic. At planning time, the optimizer reads those rows, applies selectivity formulas, and arrives at a row estimate. If your data changed since the last analyze, the formula runs on stale inputs. Here the planner estimated 48,000 rows from the order scan, sized the hash table accordingly, and chose a hash join. If the real pending orders were 2 million, that hash table would spill to disk, all because the leaf estimate was stale. After analyze, we can query PG_stats directly. We see the number of distinct values, how many most common values were captured, and how many histogram buckets exist for each column. This is exactly what the planner reads when it builds a selectivity estimate. We seeded 100 rows and ran analyze, then bulk inserted 99,000 more rows without reanalyzing. PG_stat_user_tables shows estimated live rows is still near 100, while modification since analyze is near 99,000. The planner is flying blind on the new data. Create statistics with the dependencies option tells Postgres that city and country are not independent columns. Without this, the planner multiplies their selectivities, underestimating rows. With it, the planner knows that filtering on both columns is far less selective than the product of their individual fractions. In a PR review, look for migration scripts that insert or copy large volumes of data but never call analyze. Also check whether queries filter on multiple correlated columns. If there is no create statistics covering them, the planner will multiply selectivities and underestimate rows, often choosing a slow nested loop join. The planner is only as good as its statistics. Stale numbers after a bulk load, correlated columns without extended statistics, and a low statistics target are the three most common causes of bad cardinality estimates, and all three are catchable in a pull request review.